Alright, welcome to my speech. This is The Cosmic Rays, Universe's Footprints by Michael Gaines. The famous astronomer, astrophysicist, and cosmologist Carl Sagan once said, "If we long to believe the stars rise and set for us, that we are the reason there is a universe." Excuse me. Does science do us a disservice in deflating our conceits? A rhetorical, thought-provoking question, to which there is only an eventual answer. But it does help to put humanity in perspective against the collective whole that is the universe. An ever-expanding frontier full of phenomena and scientific discoveries, some unearthed and others continuing to stay undiscovered. One such research topic of discussion is cosmic rays, which are essentially the radioactive leftovers of natural cosmic cycles. Almost entirely harmless to us humans on the surface of Earth because of the atmosphere, but deadly when exploring outside into space itself. Although cosmic ray phenomena may not seem completely pertinent to the matter at hand, the truth is that it permeates throughout the universe and even our own bodies, usually as remnants of periodic air showers, or the thousands of wayward rays that pass through our bodies every single minute, though the radiation levels are too low to be a major concern. First and foremost, what exactly are cosmic rays? In the simplest definition, cosmic rays are essentially energetic subatomic particles that arrive from outside the Earth's atmosphere. At their base atomic form, cosmic rays are generally comprised of 50% protons, 25% alpha particles, 13% carbon, nitrogen, oxygen nuclei, 1% electrons, and 0.1% gamma rays. The unit of measurement used in reference when discussing cosmic rays are electron volts, or EV for short. Through extensive study of the cosmic rays themselves, the particle acceleration processes behind them, as well as the composition of the sources of these rays, can be fully comprehended and understood. Beyond the scope of current study, one phenomenon of cosmic rays continues to perplex: the ultra-high energy particles that are above and beyond accelerated past the constraints of supernova explosions. Just another reason that some things are just unknown to us about these particles themselves. Secondly, the profound question of what the sources are of these discernible cosmic rays. From where in the cosmos do they spread? There are three specific clarifications of cosmic rays, each spanning from separate parts of the universe itself. 1. Galactic cosmic rays, which form from outside our solar system. Then there's anomalous cosmic rays, which form from the interstellar space at the edge of the heliopause, and are a result of ions repeatedly colliding against each other, the termination shocks causing an acceleration which then produces the anomalous cosmic rays. Finally, solar energetic particles, which are usually produced from solar flares from the sun or from other celestial bodies, usually stars, supernovas, stuff like that. Although they aren't covered in the collective term cosmic rays anymore, I think it's important to note that X-rays and gamma rays as well used to fall under the term. Thirdly, in what way these cosmic rays affect us. One is through visual stimuli, such as through the aurora borealis or the aurora australis. They can appear in a variety of colors, and it's basically these cosmic rays interacting and falling into our atmosphere in such a way that we're able to see this visual stimuli. The availability of cosmic rays also helped immensely in scientific pursuits, such as in the 1930s to the 1950s, where the Large Hadron Collider and other such high-energy colliders were merely but a dream. Cosmic rays served as a major interest to scientists studying high-energy physics, and so led to discoveries of the muon and the positron, two abstract subatomic particles. As an aside, particles formed from the sun were specifically excluded for intensive study. The sun itself serves as a continual fountain of cosmic rays coming down, as solar flares erupting from the surface. From information provided by these solar particles, coinciding with studies conducted through spectroscopy, it was determined that the elemental and isotopic composition could be finally realized. In conclusion, I'd like to say that space, the final frontier, is filled to the brim with scientific phenomena, both within and outside of humanity's understanding. Cosmic rays stringing along the stars helped to stem studies and research that expanded the limited knowledge of the observable universe, even outside of scientific pursuits. These rays amazed observers, with auroras lighting up the night skies and solar flares that continually erupt from the sun. And so, I'd like to end it with a quote from Nikola Tesla. According to my investigations, the sun emits a radiation of such penetrative power that it is virtually impossible to absorb it in lead or other substances. This ray, which I call the primary solar ray, gives rise to a secondary radiation by impact against the cosmic dust scattered through space. We call it the cosmic ray, and it comes, of course, equally from all directions in space. And that concludes my speech. And audience?